Welcome to the Explainer. Today, we're on a quest for the perfect recipe. Now, we're not baking a cake, no. We're on a mission to create a futuristic wonder material. We're going to crack open some dense scientific research and turn it into a pretty amazing story of innovation.
So, take a look at this. This is graphene oxide. It's an incredible material, it's super thin, super strong, and it could literally change everything from medicine to how we store energy. But, and it's a big but, there's a huge catch. The way we've been making it, well, it's a bit of a mess. It's expensive, it's complicated, and it can even create toxic gases. So, yeah, we really need a better way.
All right, here's our game plan for today. First, we'll get into the problem with this wonder material. Then, we'll check out the old school recipe. After that, things get fun. We're diving into a scientific bake-off with a very surprising new ingredient. And finally, we will reveal the winning formula that makes this whole process better, cheaper, and greener.
Okay, first up, let's get right to the heart of the challenge that scientists were really trying to tackle here. The mission was really clear, but definitely ambitious. Find a better recipe. One that's cheaper, so more people can actually use it. One that's greener, so it doesn't harm the planet. And crucially, one that doesn't sacrifice any of the amazing quality of the final product.
Now, to really appreciate the new recipe, you gotta understand the old one. And we're not talking about something that was invented last week. This is a chemical process that has been evolving for, get this, over 150 years.
You can see here, scientists have been tweaking this process since way back in 1859. Each method was a step up, and the Hummer's method from 1958, well, that became the gold standard because it was faster and a whole lot safer. But even then, it still wasn't perfect, not by a long shot.
So, how do you improve on a recipe that's been the king since 1958? Well, you have a bake-off, of course, a scientific bake-off. Researchers set up this awesome experiment to systematically test all the different ingredients and methods to find the perfect combination. So the researchers decided to focus on three key things. First, how do you prep the graphite? Should you heat it up, blast it with sound waves, or just leave it alone? Second, what about the purity of the graphite you start with? And third, the secret ingredient, what they call the auxiliary oxidant, which is basically a chemical helper that really gets the reaction going.
But honestly, the most exciting part of this whole bake-off was a new, eco-friendly ingredient, something you might actually have in your laundry room. And this is where the story gets really, really interesting.
So, in one corner, you have the old champion, sodium nitrate. It works for sure, but it can release some really nasty toxic gases. And in the other corner, you have the new challenger, borax decahydrate. Yep, you heard that right, borax. It's safe, it's natural, it's easy to find. But the big question was, could it really go toe-to-toe with a powerful but hazardous chemical?
Okay, so with all these different combinations of ingredients and methods, how on earth do you pick a winner? You can't just eyeball it. You need a super smart, totally unbiased judge to crunch all the numbers and make the right call.
And that judge has a pretty intimidating name, the Topsys-based Taguchi method. But don't let that name scare you. It's basically a super powerful statistical tool. Think of it like a supercomputer that can look at a bunch of different quality factors at once, like the chemical structure, the stability, all of it, to find the one single recipe that is truly the best of the best. It does this by figuring out which mix of ingredients gets you closest to perfection and furthest away from the worst possible result.
And now, the moment of truth. This graph right here is the final scorecard from our super smart statistical judge. It shows us exactly which ingredients came out on top. The higher the peak on the graph, the better that particular ingredient performed. So, who are our winners?
And here it is, the winning recipe. And, wow, it is full of surprises. First off, preheating the graphite was the best prep method. Second, the eco-friendly borax was in fact the champion oxidant. But here's the biggest shocker of all. Using less pure and therefore much cheaper graphite actually gave them a better result. I mean, who would have ever guessed that?
So, what does all of this actually mean in the real world? I mean, why does finding this perfect recipe matter so much? Let's break down the impact.
This number right here is an absolute game changer, a 55.55% improvement. Now, this is measured by something called the carbon-to-oxygen ratio. Why does that matter? Well, think of it this way. The higher that ratio, the closer the material is to being pure, pristine graphene, which is what gives it all those amazing properties. So a jump this big means the quality of the final product is just way, way better. So the bottom line is this. We now have a clear blueprint for making this incredible material that is at the same time cheaper because it uses less expensive stuff to start with, greener because it uses a natural, totally safe chemical, and just plain better because the final product is so much higher in quality. It's a win-win-win.
This whole quest for the perfect recipe was a massive success. And it really leaves us with a fascinating question, doesn't it? What other amazing materials are out there just waiting for a little bit of smart, creative science to unlock their full potential? What's going to be the next perfect, sustainable recipe we discover?